Hello, well, welcome to June's meetup of DataPub. So we are enjoying bringing together people who love public data sets and love to use them either in combination with one another or in combination with their own proprietary data. Our goal here is to bring different experts together to talk about best practices. So please use the question and answer button anytime during the talk, and we'll read off your questions during the after each session, following the speaker presentation. So just use that. And I'll go ahead and ask those to each speaker. So we have a code of conduct. I'll put that in the chat bar, but just so you know, we just are into practicing kindness here. And then now I'm going to turn this over to our very own data expert, our open data enthusiast, Prashant, for his opening remarks.
Thanks, Nico. Hi, everyone. I'm Prashant, and I lead the marketing and developer relations team at Timescale. TimescaleDB is an open source time series database built on Postgres. Time series data is a series of data points that's indexed in time order. And we believe that all data, most data is time series data, and that there are many interesting, important things you can do with time series data, and that's the foundation of the company. Personally, I find it really useful to use Timescale for all my public data sets projects. And I'm also an open data enthusiast, just like many of you here on this call. I encourage you to visit our website for more. It's timescale.com. So without further comment, let me introduce today's speakers. Our meetup today is titled Cataloging the World, Medicine, Tweets, and Beyond. Our first speaker is Tudor. He's a professor of medicine at the University of New Mexico School. Tudor's talk is centered around his current project, DrugCentral, which is a fully annotated resource that maps active ingredients to pharmaceutical products. It catalogs chemical entities, mode of interaction, therapeutic indications, and side effects. DrugCentral captures its data from the US FDA, EMA, and PMDA, as well as other regulatory agencies. Following Tudor will be Suhem. He's a senior developer advocate at Twitter, in which he focuses on helping the academic research community succeed on Twitter's developer platform. Because of some issues with Zoom, Suhem's talk was recorded a couple of hours ago, but rest assured, Suhem is here and he's on the call, and he'll be available to answer questions. Suhem's talk is around Twitter Developer Labs, which is the new version of Twitter's API, with what's new with the API and how it's different. He'll give us a code walkthrough of sentiment analysis on Twitter data using Python. So with that, I'm going to turn it over to Tudor. Tudor, it's all you, and enjoy it. Thank you.
All right. Can you guys hear me okay?
Yes, we can.
So I want to thank Nico and Prashant for giving me this opportunity to address an audience that is not necessarily directly engaged in pharmaceutical research. And I thought I would put some context into why we're developing this database and why we think this is part of a bigger picture. And since this is a DataPub talk, I should mention that the data is completely available at DrugCentral.org. So I guess what's important is to try to answer the question, what is a drug? So to any scientist doing pharmaceutical research, a drug is essentially a substance that they use to perturb a living system. And typically the term drug is reserved for those that are used in animals and humans. On the other hand, a pharmacist or a physician, a nurse, a patient, when they use the term drug, they typically mean a substance that they administer to patients to achieve a clinical effect. Of course, drug has a different street meaning, which we won't dwell into today, but it's important to recall that we typically, and in the context of DrugCentral, we will refer only to approved drugs, which means that regulatory agencies such as the US Food and Drug Administration or the European Medicines Agency approved it upfront. And of course, it's important to recall that drug carries multiple meanings, but that's the meaning we will use today. Why do we care about drugs? For starters, according to recent statistics, at least 30% of the elderly 65 and above use 8 or more prescription drugs daily. You can imagine that is a lot of medication, and the elderly take over a year different, more than 18 prescription drugs. And of course, most of us have had the occasional headache, and we had to take what's called an over-the-counter drug or a prescription drug once in a while. So sooner or later, I guess we all need it. So to put these things in context, why do we care about drugs? I'd like to point out that there are 3 pillars in drug discovery, and they all rest heavily on informatics and data science these days, as well as machine learning, or what the hype cycle calls artificial intelligence. So of course, when it comes to diseases, it's important to know the data that we collect from patients. That's called electronic medical records. There's an area of medicine called nosology, which deals with naming medicines, etc. Then when it comes to targets, we care about what's called these days knowledge graphs, and they help us to, when coupled with machine learning, with the process of target identification. And I should point out that when it comes to drugs, targets are simply the proteins or the biological processes upon which those drugs work on. And then, of course, we've already covered drugs. There's an area called virtual screening. There are people who design vaccines, but they all use all sorts of informatics. And I've been fortunate enough to be funded through a project called Illuminating the Druggable Genome. And we initially started that project by carefully mapping all the drug targets that are known and annotated. So the data is in DrugCentral, and we typically cover about 1,000 drug targets and more than 1,500 drugs. And then we've also covered in extenso a discussion of the drug elimination process. So there's a separate paper in Nature Drug Discovery dedicated to illuminating the druggable genome. And then as of February this year, we applied the same discussion to therapeutic modalities for rare diseases. Everyone who's interested can explore those links. So going to DrugCentral and quickly looking into the data structure, the reason we started this project was to try to reconcile the 2 cultures, the patients slash physicians versus the scientists. So somewhere in the middle, you'll see a green label that says active pharmaceutical ingredient. We used to abbreviate that as API, but unfortunately, computer science has taken over that abbreviation, so we don't use it anymore. On the other side of the active ingredient, you see pharmaceutical formulation. So just mapping between those 2 is an ongoing process. It's quite extensive. And as we map that information, we then extract relevant pieces of information about the drug targets and how these drugs work, what's called the mechanism of action or bioactivity. And then from the pharmaceutical formulations, we go through the dark labels and extract indications, contraindications of label usage, etc. And all this gets stitched together, and it's centered around a structural identifier of a drug. And what you see in this particular picture is a drug called 𝗥𝗲𝗃𝗃, and the many identifiers that are available through different resources, whether it's the Guide to Pharmacology or IUPHAR, RxNav, which is maintained by the National Library of Medicine, as is MESH, by the way. Then there are databases such as DrugBank and SciFinder and KEGG, which provide additional information. Campbell and PubChem, they provide bioactivity data, and 𝗥𝗲𝗃𝗃 is an ontology resource. So all these external classifiers, if you look at the medical subject headings or MESH, you see that this drug is classified as an anti-infective, and then you further drill down until you find that it's an anti-HIV agent and the CCR5 receptor antagonist. The ATC codes have also a layered tree-like approach from anti-infectives all the way to antivirals, and then it has a specific code. And then 𝗥𝗲𝗃𝗃 has a similar approach. And then, of course, the FDA maintains its own classification. So how many drugs do we cover in DrugCentral? Currently, as of end of March 2020, we cover 4,642 active pharmaceutical ingredients, and about 1,800 of those are FDA marketed and approved, and then about 440 are discontinued or no longer marketed. And the way to think about these is to consider the relationship between the pharmaceutical formulations, which at the moment is more than 110,000. And then, of course, the number of active ingredients per formulation. So if you look in this graph at the count of 1, the over-the-counter medicines are about 34,000. And then the prescription medicines, or the RX, they are close to 50,000. So what that means is that we have a large number of ingredients that are unique to the over-the-counter, but even more in the prescription. And then as you progress to 2 ingredients or more, you see that the orange starts to dominate. So most of the over-the-counter medicines literally contain 2 or more active ingredients. This is just to give you an idea. There are currently more than 5,000 formulations of acetaminophen, also known as paracetamol. So just on the US market, you can get, whether you go to Costco or CVS, Walgreens, Walmart, a lot of places, they sell their own brand of acetaminophen. It's often called Tylenol, but not always so. And sometimes it's formulated in combination. So for instance, Excedrin migraine contains acetaminophen, aspirin, and caffeine. Or you can also find a painkiller formulation with hydrocodone, which is actually an opioid, so it's a prescription drug. There are syrups for children. There are special formulations for menstrual relief, and several other formulations. So to give you an idea about this capitalism in the pharmacy, this pretty much sums it up. Even though the over-the-counter medicines are about 300 active ingredients compared to the prescription, which is 1,500, at the end of the day, you'll see more than 50,000 over-the-counter formulations. And that is also explained by the different price fixing. In Australia, one of the top 3 pharmaceutical companies in the UK, Reckitt Benckiser, was described in the news as trying to gauge the price. So there were exactly the same ingredients between the Nurofen back pain and Nurofen migraine. So they both contain ibuprofen lysine, which is equivalent to 200 mg of ibuprofen, but it is sold at twice the price, even though it's made by the same company. So going back to this slide with the Tylenol, if you have a headache and you don't want to spend a lot of money, it is wise to read the package insert to see the exact content, and you'll probably be able to buy the same drug for half the cost. Just to give you an idea, this is not a unique phenomenon to acetaminophen or ibuprofen. These are the top 10 listed by number of formulations. So at the bottom is the first one, acetaminophen or paracetamol, which has about 5,000 formulations, followed by dextromethorphan and phenylephrine. And those of you who used Robitussin, you should know that it contains all the ingredients in Robitussin are listed in this list. The only drug that's prescription on this list is hydrochlorothiazide. This is a diuretic, and it's often used to treat hypertension and related problems. This is the website for DrugCentral 2020. If you go right now to DrugCentral and mine it, you will see there are also drugs that are featured in the news. For example, chloroquine and hydroxychloroquine have recently been used to treat the COVID-19 disease. And of course, there are additional places that you should be aware of. There's a download button, and if you click on that, you can get the complete data set that's currently in DrugCentral. So in other words, you should find out more if you go to DrugCentral, or if you are interested in the full data load. So I'm going to spend, that was the introduction, I'm going to spend 5 minutes just to illustrate the content of DrugCentral, just in case you might not be aware of it. So if you search for hydroxychloroquine at the tab, this is what you get. First, it tells you about the STEM definition, that it's a quinoline derivative. This is a classification system. So is the CAS number, chemical abstract services. They have a unique number designated for each chemical. There is a chemical structure that you can download in several different formats, such as SMILES or 𝗏𝗏𝗀𝗏. There's a brief description of the drug. It tells you, for example, that this is a chemotherapeutic agent used in malaria. The drug dosage, it will tell you that it's available in oral formulation. That's what the O stands for. The unit says gram, and then the dose is 0.52 grams or 520 milligrams. It was first approved in April 1955 by the FDA, and the approval went to the company that later became Sanofi Aventis. I don't think it was called Sanofi Aventis in 1955. What's equally important, and what you should be aware of, is that there is a long list of adverse events. So in this particular case for hydroxychloroquine, there are 528 entries. This data is processed from the FDA Adverse Events Reporting System, and you have a likelihood ratio. This is calculated according to a specific formula. The part that says drug ineffective is part of this. And my assumption is that these reports are related to the indications for this drug, which, if you look down here, it's malaria, as well as rheumatoid arthritis and lupus erythematosus. So my guess is that the complaints about the drug being ineffective are probably more related to lupus and rheumatoid arthritis than to malaria. You will see as you proceed further that you can get things like drug intolerance, joint swelling, treatment failure, etc. What's equally important is that you can search. So for example, in the cardiovascular domain, there is something called the QT prolongation. So if you just search for a particular side effect, you can find it at the prompt. So if you're not interested in downloading the entire database and processing it automatically, but you're just curious about the side effects of a particular drug, if you search for that particular side effect, you should be able to find it. What's equally important, the pharmacologic action. So in this particular case, the ATC classification would tell you that this is an antiparasitic drug. It belongs to the aminoquinoline class, and it's used to treat malaria. So having established that, what's also important is to see the many uses of hydroxychloroquine. So for example, once you scroll past the indications, you will see that this drug has a number of off-label indications, including more recently coronavirus infection. So I'm trying to highlight that here. Hopefully you could see that. And then of course, there are also contraindications such as psoriasis, alcoholism, etc. We also take a look at pKa. So that's something to do with chemistry and acid-base phenomena. For drugs that are included in the Orange Book, which have patent information, that tab will be populated here. So it would tell you that there are currently patents that grant exclusivity both from a marketing perspective from the US Patent Organization, but also from the FDA to formulate this drug. The targets for this drug are listed here. We tend to often list the human targets first. Of course, in this particular case, you'll see at the bottom where it says SARS-CoV-2. This is, of course, the virus responsible for COVID-19. And it tells you that in scientific literature, they found this drug to be effective against the virus. There are several external references, which I mentioned earlier, and then there are pharmaceutical products. The pharmaceutical products in particular, if you are interested to learn more from a patient perspective, once you click to this, it takes you to a site external to DrugCentral. It is called DailyMed. And DailyMed is maintained by the National Library of Medicine. So, for example, you can find out that this particular package insert is related to 𝗥𝗲𝗃𝗃𝗀𝗃𝗃𝗀𝗃, and it's a 200 mix formulation, manufactured by Mylan Pharmaceuticals, etc. And then it has all the chapters that are particularly listed in a package insert, not just the clinical pharmacology indications usage, but all the way to adverse events, how it is supplied, and then what else is in the drug tablet. So that pretty much concludes my presentation. And at this point, I'll be happy to answer questions if there are any.
Thank you, Tudor. I'll give a minute out there just for anybody to have any questions at this time. If not, also, we'll be sending out a follow-up with recordings and links to all these resources. If you have any questions, we'll also put in a place where you can reach out to us or Tudor about this presentation. So John Cooper has a question for you, Tudor. Can you talk a bit about how you refresh the data?
This database itself is a bit of an arduous process to assemble. We literally have to process data from FHIRs, manually enter the information about the chemical structures, and there's a lot of curation steps. So just the assembly itself takes about a month, and we typically refresh it about every 6 months. We've had a hiatus between the last version of the database, which was October 2018, to this one. That was due to personnel reshuffling in my team. But we should be able to do this on a more continuous basis in the future.
Any other questions? All right. Well, thank you again. And let me, as we've said, that we are going to have Suhem from Twitter Talk, but I'm going to share his recording with you. So let's just, there we go.
Hi, everybody. My name is Suhem Parack, and I'm a developer advocate at Twitter. And I'm super excited to be here and to talk to you guys about Twitter Developer Labs. So thanks to Prashant and the Timescale team for having me here. So let's get started. So as I mentioned, my name is Suhem. I'm a developer advocate for academic research at Twitter. I mostly work with academics to help them do their, or help them use the Twitter developer platform to, for their research, academic research with Twitter data. For this meetup, I wanted to talk to you guys about Twitter Developer Labs. So we first get into what Twitter Developer Labs is. Then we're going to get into what are some of the new things that are part of Twitter Developer Labs. After that, we're going to get into what are some of the new APIs that are part of the labs. And then finally, we'll get into a code implementation and then perform sentiment analysis using the service called AWS Comprehend, which is a service offered by Amazon Web Services. So firstly, what is Twitter Developer Labs? So Twitter Developer Labs is the newer stack or the newer endpoints that Twitter is making available to developers. As we ship out new endpoints, we ask for feedback from developers, and then we iterate over those. So if you're familiar with some of our old endpoints, like the search endpoints of basically the standard search that you get as part of like Tweepy or our tweets and things like that that you use, those are our older endpoints, right? So you have search endpoint that gives you tweets for the last 7 days. You had or used to have a streaming endpoint that gives you the 1% stream of data or tweets as they're being generated. But with Twitter Developer Labs, we're providing this data in using our new next generation of APIs. So it's on a newer stack. The JSON response is obviously slightly different. The authentication mechanism is slightly different, and a lot of cool things that are part of Labs. So some of the new features, one is obviously the one that I'm most excited about is context annotations. So context annotations is basically like first party NLP, or like you can think of it like topic modeling done for you. So let's say you have a tweet that talks about, like, let's say somebody mentioned that I went to watch the Baltimore Ravens and I really enjoyed watching Lamar Jackson, right? So now in this tweet, if you wanted to like do some kind of like topic modeling or like entity extraction, then you might use your own, like you might write custom code that does that. Or some people might do like use a third-party service that does this entity extraction for them. However, Twitter makes it available directly to you, which is really awesome. So like now as part of your JSON response, you'll have context annotations, and that in that there'll be like identified entities for you. So like, for example, you'll know that Baltimore Ravens, for example, is referring to the football team. And then Lamar Jackson is a person or a sports personality and things like that. So this kind of information that's being made available directly from our APIs is pretty powerful, because then you're not spending so much time doing this NLP and topic modeling for yourself. You're able to pull this information out of the JSON object itself. Then we also have this idea of fields. So by default, when you ask for like a tweet using recent search, or like you hydrate a tweet, you basically get the tweet ID and you build the actual, get the text and things like that using the tweets endpoint. By default, you get the ID and the text only, right? But you might want additional things like let's say, the user information associated with it and things like that. So now you can use the different fields to get the data that you need. So instead of getting everything back, you specify what are the things that you want back as part of your JSON response, which is pretty good because it includes things like polls. So like if there's a tweet about a poll, you can actually get information back about what were the different options, how do people vote, what was the duration and things like that. And then similarly, you can actually build your user object as much as you want, so include things like username, things like that, which is different than what we had in the standard search. So what are the APIs that are available as part of Developer Labs? So first, obviously, the sample stream, which is essentially 1% of approximately 1% of the conversation that's happening on Twitter. Variation of that is filtered streams. So sample stream gives you all tweets in all languages, whereas you might, let's say, be only interested in a subset of those tweets. So let's say you want all tweets in English or Spanish or Hindi or something like that. So you can actually use different operators that are part of filtered stream, which is really powerful. So a filtered stream allows you to use a bunch of new operators. You can extract, you can remove things like, maybe you don't want any retweets in your data. So you can use the operator for like is retweet and then do a negation on that. That pulls out all the retweets for you. You might want all tweets that have images or have media, or only part of a certain language and a place and things like that. So you can do all of those things with our new powerful operators. And the recent search endpoint is obviously gives you last 7 days of tweets, a sample conversation around that. And again, that one is also using the newer operator. So that lets you get the data in a really nice, like fine-tuned manner by focusing on really what you're looking for. Then there is the tweets and users. So tweets and users is basically a way of building the actual tweets object and the users object using a tweet ID, user ID, things like that. And then that's generally used by people that have a list of like tweet IDs and they want to build the actual tweet JSON using those tweet IDs. And then finally, there is this new API which is hide replies that lets you hide replies to a tweet based on certain criteria. So you might want to like hide replies that might be offensive or they might have certain topics that you're not interested in, things like that, you can always use the hide replies endpoint for that. So before I get into the actual code implementation, we're going to use the sample stream endpoint, and we'll do sentiment analysis with AWS. I wanted to point out a few resources, right? So first, in order to use the Twitter Developer Labs, you need to go to developer.twitter.com/en/apply-for-access, because you need to have an approved developer account, and only then you can use it, right? Then after that, you have to make sure that you create an app and that you enroll that in labs. So this link here, developer.twitter.com/en/labs, that has all the documentation, and we're going to take a quick look at it right now, but that has all the documentation, sample code, and things like that that can help you get started right away with Twitter Developer Labs. Similarly, we have the GitHub collection, which has our sample code for labs as well. And then finally, if you guys have any questions, you can always reach out to me, Suhem Parack, that's my Twitter handle, and also Twitter Dev, which is our team's handle. We're always looking for feedback about Twitter Developer Labs and how you guys use it. So actually, before we do the code implementation, let's take a quick look at how you might apply for an account or how you might build an app, right? So first, you need to have obviously a valid developer account. Then here, if you go to your app section, there's this option of like creating an app. So you specify the app name, what this application does, and obviously you have to like explain what your app will be used for, because you need to be in compliance with the developer policy and make sure that your use case, you have a valid use case for using this, right? So make sure to fill this out. Once you fill this out to create the app, you will get a consumer key and consumer secret, which is what you will use in order to connect to the Twitter API. So you're going to need to do some kind of authentication. We use the bearer token, and in order to generate the bearer token, you're going to need the access key and, the consumer key and consumer secret. So that's what you'll get from here. And then once you have it, then obviously you can start using the Twitter Developer Labs. Also, because we'll be using AWS, you will need to get your, create an IAM user and get your AWS access and secret, and make sure that you specify that as well. But before we get to any of that, I wanted to first walk you through the documentation that we have. So if you go to developer.twitter.com, if you go to labs and docs, you'll see here that you have the documentation for each endpoint. So here we have some documentation about what's new. So the things that I mentioned, the fields, annotations, expansions, things like that, and then the different endpoints. So let's take a look at maybe one of these. So let's take a look at a sample stream. So this streaming endpoint, generally the way that it's structured is that there's an overview, there's a quick start, which actually includes code samples. So you can just like copy paste these code samples, replace the consumer key and secret that you got from from your app, and then obviously you might change the rules. So this is saying that give me all tweets about that has the word dog and has images, so all dog pictures and things like that. Obviously you can edit it to meet your criteria as well. And then there's obviously some guidance around what are the operators that are available. So as I was mentioning, you can filter by language. You can check if it's from a verified by Twitter and things like that, has images and so on and so forth. Now, if you look at the quick start, there's this thing called Postman collection. So we've already created, so Postman is basically a tool that lets you make API calls instead of like using curl in your terminal and things like that. So we've pre-created these calls for you. So all you need to do is like replace your keys, and then you're able to make the call. So let's take a look at a sample call in Postman, right? So here I have this is a call to the tweets endpoint, right? So if I specify the ID of the tweet that I want the data for, so I'll specify that here. So this is my tweet ID. And now this is what I was talking about earlier. So instead of getting the entire JSON back, you actually have control over what fields you want to return, right? So there are things like user fields, place fields. So like, and then within that you specify, do you want all of them, or like you can add and remove as many as you want. So it really depends on what data you're looking for. So for this call, I wanted to showcase this thing, a poll fields, right? So this tweet was actually a poll that I created, and just wanted to showcase how powerful it is to now get the data about polls as well. So I'm going to go ahead and make this API call. So if you see here, generally it contains two things. One is the data, and one is this includes. So includes is with all the expansions that we add here. So like we were saying that you can expand on like media. So like if it was a video, some metadata about the video. This was a poll. So obviously here you can see how long the poll ran for, when did it end, what were the different options, how many votes did each get, and things like that. So, and what's the current voting status for that poll. So this is actually pretty powerful that you just get the postman collection directly from our website, and you can have full control over what kind of data you want coming back from these different endpoints. Now I'll do a quick walkthrough of the sample stream endpoint, which is obviously the 1%, approximately 1% of the conversation on Twitter. And then we'll use AWS to do sentiment analysis, right? So I've broken down this into like 3 components. First is we need to get an access token using the key and secret that we got from when we created our Twitter app. Then we're going to call the actual Twitter API for sample stream. And then we're going to filter for tweets that are in English and then perform sentiment analysis on it, right? So let's get started. So first, in order to get the access token, let's create a function. And this is, let's call it get bearer token. And then this can take a key and secret, right? And then here we'll use the request package. So let's do requests. I'm gonna import this. And then I'll do, so this is a post endpoint. So I'll do post and I'll pass 3 things. So one is the auth URL itself. And then I need to do the authentication. So key, secret. And then finally, I need to specify the grant type. So grant type and oops. This is client credentials. Okay, so here from this response, I'll get the access token out. So let's do oops. And then here I'll return the access token from this body. Okay. Now this is my API call to get the bearer token. Next, I need to use this bearer token to connect to the sample stream endpoint. So for that, I'll do create a function. Let's call it stream connect, which will take in the token. And then I'll do again use requests package, and this is a get call. Again, takes 3 things. First is the stream URL itself. And then I need to add the header for it. So here, authorization, and then we use the bearer token. So I'll pass the token itself. And then finally, because it's a streaming endpoint, so I'll do stream is equals to true. Okay, so now I'll go over the response and see, I'll pull the tweet IDs first. So let's see, let's do response line in. And then if there is a response, so if, oops. And I'll load it into the tweet object, or yeah, so I'll load it as a JSON. So then I'll do JSON dot loads, and then this response line. Oops. So let me go ahead and import this as well. Yep, and also, yeah. Now, once I have this, then I need to check that if it's in English. So then if tweet and each object is contained within data. So I'll do if data and then lang is English. Then let's print the ID for now. So then let's do tweet. Oops. data ID. Okay, let's try and run this. So here we'll do token is equal to get better token, and then we have the consumer key, consumer secret, and then we'll do while true. Then we do stream connect with this token. So this should print the tweet IDs for us. Data lang is English. Yeah. Okay, let's go ahead and run this. So you see now it started giving us the tweet ID. So far so good. Now the next thing that we need to do is instead of printing the ID, we need to do the sentiment analysis on it. So what we'll do is instead here, we'll get the text from here. So we'll do tweet and then there's the text. So if it's in English, first get the text, and then we want to do sentiment analysis. So now in order to do the sentiment analysis, let's set up the comprehend SDK here. So let's do import 𝗏𝗏𝗃. So 𝗏𝗏𝗃 is the one for AWS. And then let's do comprehend is equals to 𝗏𝗏𝗃 client. Okay, so now it needs to have 4 things. First is the service name, and this is comprehend. Then we have AWS access key ID. And then I'm going to get this from my config file. So this config file I already created an IAM user and got the AWS access key and secret. And so I'm simply pulling that from here. So obviously you'd have to first create that when you're from your AWS console. Then AWS secret access key. And then here, let's get the secret key. And then finally, you have to specify the region name as well. The region name is, again, here I specified my region in my config file. So I have access key ID, secret access key region name, and I have this initialized here. So now, instead of printing the ID here, what I'm doing is I can go ahead and clear this. Here I'll print, I'll do comprehend, detect sentiment, right? And now I'll pass it the thing. This will give me the JSON, and from that I want to pull the sentiment. So now what do I pass it? So 2 things: text, which is this text itself, and then we do the language code. And then I'm going to go ahead and run this. This should ideally start to give me the sentiment. Yeah, so you see now it's giving me the sentiment each time as well for the tweets that are coming in. So yeah, this was hopefully this demo was helpful. And make sure to check out developer.twitter.com/en/labs. Check out our different endpoints. Apply for an account if you already haven't applied for one, and then let me know how you guys like it. Thanks again, the Timescale team, for having me, and I look forward to hearing feedback from you guys. Thank you.
Great. Thank you for the video. Suhem is actually online now, so if you guys have any questions, please feel free at this time to ask away. All right, well, as I said before, as I mentioned, we'll be sending out follow-ups to everybody with recordings and links to the resources and where you can reach out to our speakers if you have any follow-up questions. But once again, thank you very much, Suhem and Tudor, for taking the time out and showing us the projects that you're working on. And if anybody would like to present at a future meetup, please let us know. We're always looking for speakers. And if you have any fun open data projects, we'd love to see it. Our next meetup is scheduled for July 21st. So you'll have links to that as well. So hold on. Yeah, and quick question, somebody just sent out a chat thing. Yes, we will be posting the link to all the resources and sending that out. So you guys will have that. All right, and thank you very much for joining us. And, thank you everybody for your time. Have a good one.
Thank you, Nico.
Thank you.